Good morning, students. Now this same chapter, complex number, and now the topic is modulus and argument. Modulus of complex number and argument of complex number. Exercise 5.2. This is a very important topic. Modulus is any complex number that denoted by z. A plus iota b is a complex number, right? What is the A? A is the real part. Then this is the point P, that's A comma B, where A is the real part on x-axis, right, and B is the imaginary part on y-axis. Now complex number modulus of z is denoted by mod z, and this is the identity of modulus of z under root a square plus b square. The square proof recursive to then applying Pythagoras theorem, right? So what is the modulus of z under root a square plus b square? For example, z equals to 1 plus 1 minus iota. This is complex number. First thing, what is the real part? A is 1 and imaginary part B is minus 1, that means coefficient of iota. And now find the modulus of z. Then modulus of z, that means mod z denoted by mod z under root a square plus b square. This question can be solved by two methods. First method is the identity. The second method then let the complex number. This is complex number in Cartesian form, a plus iota b form. Now is equated in polar form. Z equals to r cos theta plus iota r sin theta. But now is a simple method. This is the identity of under a square plus b square, and now under A, here A is a 1 and B is minus 1. The square of 1 is 1. The square of minus 1 is a 1. Then root 2, this is the modulus of. This is the first answer. But same question, find the modulus and argument. Now look here, student, what is argument? Argument, yeah, is the other name, amplitude of z, then denoted by theta, right? But this topic is solved by two methods, but now it's a very simple method. First thing, let this angle is alpha, and now find tan alpha. Tan alpha equals to mod of b upon a. This is the identity. But alpha is not amplitude. Argument is not amplitude. Amplitude is denoted by theta. So theta, amplitude of z is a notation of amplitude of z, yeah, otherwise argument of z denoted by theta, and theta is depend. There are four quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. When theta lies in first quadrant, then theta equals to alpha. So alpha value is same theta. But when theta lies in fourth quadrant, then theta equals to minus. And then next is second quadrant, but this is the pi. When pi minus alpha, and theta equals to pi minus alpha. This is second quadrant. Third quadrant, then theta equals to negative pi minus alpha. Now look here, this is the example. Let complex number 1 minus iota. Then real part is a is 1, imaginary part is b is minus 1. And first thing, अगर आपको amplitude find करना है, now find tan alpha. Tan alpha equals to mod of b upon a, right? Then tan alpha equals to b is minus 1, a is 1. Then mod is always positive value, right? So tan alpha equals to 1. Tan theta will be one value, that is the 10, 45, 20, 10 pi. Then 10 to 10 cancel, alpha equals to pi by 4. This is alpha, this is not amplitude, this is not argument, right? Argument and amplitude are denoted by theta. So now, point, real part is 1, imaginary part is minus 1. Then point P lies on the which quadrant? Then first quadrant, real part and imaginary part both are positive. Second quadrant, real part negative and imaginary real part is positive. Third quadrant, both are negative. And fourth quadrant, then positive and negative. So real part is positive and this is negative. Then theta lies in fourth quadrant. Theta lies in fourth quadrant. Then theta equals to minus alpha. Then theta equals to minus alpha is pi by 4. So student, this is the modulus of z. And this is the amplitude of z. But now this complex number in Cartesian form. Complex number in there are two forms. One is the Cartesian form, a plus iota b form is the Cartesian form. But now the second form, then complex number in polar form. So what is the polar form? When z equals to r cos theta plus iota r sin theta. Where r is the modulus of z and theta is the minus pi by 4. Then z equals to r is the root 2, then root 2 is common, and now cos theta is minus pi by 4 plus iota sin minus 1. And now simplify, and root 2 as it is, cos minus theta is a plus cos theta, and sin minus theta is a minus sin theta. So this is the complex number in polar form. In polar form के लिए about two things, modulus and argument. Modulus and argument. Z equals to r cos theta plus iota r sin theta. This is the complex number in polar form. And a plus iota b form is the complex number in Cartesian form. This is another example. Z equals to 1 plus iota root 3. This is another complex number. Where minus 1 plus iota root 3. Right? When a real part is minus 1, b imaginary part is root 3. First thing. Now find modulus. Modulus is under root a square plus b square. So what is the value of modulus of z? Then under root square of minus 1 plus square of root 3. Then square of minus 1 is a plus 1, square of root 3 is 3, then 3 plus 1 is 4, and square root is 2. First thing is the modulus of z. Now second thing, now find the amplitude, and tan alpha equals to b upon a, where b is root 3 and a is minus 1. But this is root 3. And now in tan table, then root 3 is a tan 60, that means tan pi by 3. Then tan can cancel, then alpha equals to pi by 3. But now point real part is minus 1 and imaginary part is root 3. Then this point is lies where real part negative and imaginary part was when theta lies in second quadrant. So now this point lies on second quadrant. And second quadrant, now formula is theta equals to pi minus alpha. Then pi as it is, alpha is pi by 3, then pi minus pi by 3, that is 2 pi by 3. This is amplitude of z, argument of z. And now complex number in polar form, right? Then r equals to r cos theta plus iota r sin theta. Here r is 2, then r is 2. Now 2 is common, then cos theta is 2 pi by 3. This is the complex number in polar form. This is the complex number in Cartesian form. So student, please solve exercise 5.2. Right, there are 5 questions, but topic is modulus and argument. Thank you.